Today I'm going to be talking about trig ratios. The three trig ratios are sine, cosine, and tangent, and I'll explain what that means in just a minute. But they're important because we can find angles and side lengths in a right triangle. And it sort of shows us another way of finding side lengths other than using Pythagorean theorem. And in the real world, surveyors use trig ratios to do their work. So, let's start. This I have labeled here sine, cosine, and tangent. So the sine means opposite over hypotenuse in a right triangle. Cosine means adjacent over hypotenuse in a 90-degree triangle. And tangent means opposite over adjacent in a 90-degree triangle. When we use trig ratios, we use 90-degree or right triangles, whichever way you want to say it works. So, with these triangles, I've got three of them here, I'm going to help you guys figure out where the adjacent side is and where the opposite side is and where the hypotenuse is. So let's start with hypotenuse. So the hypotenuse is going to be your longest side. However, see, we have A, B, and C. If it's not clear which side is the longest, it makes it difficult. Also, since we're using variables, they're not numbers, so once again, it's hard. If these lines aren't obvious to tell what lengths they are and you don't have numbers, it's a little difficult to find the hypotenuse unless you have a 90-degree angle. Then you know that the hypotenuse will always be across from the 90-degree angle. So that is always, always, always where your hypotenuse is going to be. So that's a little nice tip there. Next, let's talk about the adjacent side. So when I say adjacent side, you're probably wondering adjacent to what? Well, an angle. So let's say if we chose this angle of 35 degrees, and I wanted to know the side adjacent to it, it would be the side right next to the angle. Your adjacent side is always going to be right next to the angle. So the opposite side now from the angle would be straight over here to B. Just think of it as like a diagonal. You're going straight and diagonal opposite of the angle. Adjacent is right next to the angle, and hypotenuse is across from the 90-degree angle. You can't really say, I guess you could say the hypotenuse is close to the angle, however, so is adjacent, and you don't want to confuse the two, so it's best to just stick with the hypotenuse is always across from the 90-degree angle. So, let's move on to this triangle. Over here, we've got 41 degrees down here. So if we want to know the side adjacent to 41 degrees, it would be B, because it is right next to the angle, also connected to the 90-degree angle. And then if we wanted to find the side opposite to it, you just make a diagonal and follow it. Opposite, that's A. And then hypotenuse is the side that is always across from the right angle, so C would be the hypotenuse. And next example, we've got 28 degrees down here. So if I want to find the side, if I want to find the hypotenuse, we have C again because it is across from the 90-degree angle. If I want to find the side opposite to 28 degrees, we'd make our diagonal and go straight across to side A. That is opposite. And then if we want to find the adjacent side, we look, okay, what's the last side left? And the side that's right next to the 28-degree angle, it's side B. So it's very important when you're doing trig ratios to know opposite, adjacent, and hypotenuse, because we're going to set up trig ratios next, and you can see opposite, hypotenuse, and everything over here. So they all are going to connect. So if you know your opposite, hypotenuse, and adjacent, you shouldn't have any issues setting up your trig ratios. So, in these triangles, what we're going to do is set up our trig ratios. So let's start with 43 degrees over here, angle A, and I want to find sine A, sine of angle A. So we look up here and we go, okay, sine is the opposite over hypotenuse. So you start at angle A and go, okay, what is the opposite? We make our diagonal. Opposite is C. And then we want to know, okay, what is the hypotenuse? Hypotenuse is always across the way from the 90-degree angle. So it's A. So the answer for that would be C over A. And I'm going to write that down really quick. The sine, it would be C over A. Sine of A is C over A. Next, if we want to find the cosine of A, we would find the adjacent to A, which would be B because it's right next to it, and we'd want to find the hypotenuse, which once again, it is across the way from the 90 degrees, so it is A. So the cosine of A would be, the cosine of A would be B over A. And now if we wanted to find, let's go with the tangent of angle B up here, we would go, alright, where's the opposite? Opposite of big B would be the side little b. And then the adjacent to this angle B would be what's right next to it, so it would be C. So the tangent of B would be little b over C. Right? Because we've got, what is it, B. So we have the opposite B over adjacent, which is C. Alright, and this next one, if we want to find the sine of C, we would go opposite, which would be A, because it's right across the way, to hypotenuse, which is B, because it's across the way from the 90-degree angle. So our answer would be sine C is A over B. A over B. If we wanted to find the cosine of C, angle C, we would go adjacent is side C because it's right next to the angle, and we would go hypotenuse, which is B, right over or right across the way from the 90-degree angle. So the cosine C would be adjacent, which is C, over hypotenuse, which is B. And the tangent of C would be, here we go, tangent of C would be the opposite, which is A, over the adjacent, which is C. So it would be A over C. And then for my wrap-up questions, I would ask, in my follow-up, I would ask, is the hypotenuse ever opposite or adjacent to the triangle? Like, is the hypotenuse ever the opposite side or the adjacent side in the triangle? And then the next question would be, can we use sine, cosine, and tangent on any other types of triangles? Thank you.